club. Sorry. And memang Taylor's Astronomical Society. I keep getting confused. Okay, so sorry. But yeah, he's from Taylor's Astronomical Society, and we are partnering with him with Taylor's Astronomical Society for today's subject, which I'm actually like super interested in. Chris, we had some discussions about this as well.
Yeah.
Where's your video? This is the time for us to check audio video. All.
Wait.
Oh yeah, make you co-host as well. Okay, I need to share on Facebook. Hello, Penny.
Hi, how are you?
Okay, not so bad. How are you?
It's really cold in Kenya.
Yeah, it's been really cold here too. Like so much rain. It's like freezing here.
Really freezing.
Well, freezing because I'm in a like air conditioned room, but
You guys are always on AC. Hi, Umu.
right.
Have you started exams?
No, not yet. Mine start on 23rd July.
When's yours, Penny?
I had one yesterday. I had one on Wednesday, and I submitted another one today, and I have one next Friday and on 30th.
And then it's over after the 30th.
And then the real life starts again.
That's true. I'm so glad you're all here despite your exams and assignments. That's pretty awesome. Thank you. Thank you so much.
Welcome.
But we haven't seen like as many sign-ups this month, lah. Probably because of the exams and assignments.
Because of exams.
Yeah. But hopefully next month we'll hopefully see more, especially with the club showcase. That one is quite interesting. I can't wait for that. Yeah, some interesting proposals already. Not bad.
Today's the deadline, right?
Yeah, today. Today, anytime today. So it can be midnight. So I'm guessing like right at the like almost midnight, I'll get like whole list.
Yes.
This is how this is how it always happens. And it's cool. It's fine. Okay, hold on. Let me just do this sharing. I need to put this live. Chris, you want to start at 7:30 on the dot, or do you want to start a little later, wait for people to join?
Wait for majority, I guess.
Okay. I'm just
Okay,
preparing it.
I'll soon be back, okay?
Okay, sure, Penny. Go ahead.
I'll just mute, but I'll soon be back.
Okay.
Thank you.
Ethan, I don't know why. Put in waiting room and admit again. My internet has been terrible, so I don't even know.
Well, I mean, I think like mine's too. Mine's pretty bad as well.
Are you using Wi-Fi?
Yeah.
I'm using data. I'm using my data as my hotspot.
Yeah, I mean like both data and Wi-Fi, they're pretty bad for some reason.
Yeah, I don't know why. It's been really, really bad.
Yeah.
Everything is slow. And it feels like the internet is running out faster. So, like with Wi-Fi, you don't feel it. With data, I'm like, I got 100 gigs and I had to top up twice. That's crazy. That's never happened before. Oh, man.
Hello.
Hi, Derrick.
Hi.
Hi. Yes. Sorry, I probably don't know most of the people here.
Well,
but
I mean,
supposed
it's
to
all right.
Hi, Derrick. Tell us a little about yourself.
Well, wow. Where do I begin? You mean just in general about or astronomy background? Astrophotography or just in general?
Go ahead in whichever, like, however you want to introduce yourself.
Okay, sure. I'm working as a university lecturer in engineering, but I've been doing astronomy since since almost 30 years ago.
That's awesome.
Started off observing the stars using my naked eye, binoculars, graduated to telescopes, 10-inch, 12.5-inch was the largest that I owned. And
wow.
yeah, I enjoy actually visually looking at the sky. And most of this was in the US, the United States. I stayed in Arizona for 17 years. Got to know a ton of awesome and really, really knowledgeable American astronomers. Some of which are of international status, like Tom Palakis. I don't know, some of you may have heard of Tom Palakis before, but there are many others. Chris Sure, gosh, what's his name again? I can't remember. He passed away, but yeah. So I started astrophotography, star photography, basically about 5 years ago. No, 2014. That makes it 6 years, right? It's 2020.
Wow.
So I enjoy starscapes, and I'm a lazy person, so I don't really like to set up a whole bunch of equipment, unlike my good friend Cress, who is very detail oriented. So I think he'll talk about deep sky imaging, right? But for me, I'm just gonna go the easy way, the easy way with a star tracker and just landscapes and stars. So and I enjoy that because I kind of find that more challenging than deep sky, But everyone has their own personal thoughts about it, and for me, deep sky doesn't appeal as much as finding a beautiful location with a very nice star background. Okay, so yeah, I guess that's kind of astronomy oriented background. Yes. Can I understand a little bit on the background of this talk? Okay, because I was just invited by Liang Qizhong, right? And yes, and of course Cress. But I was approached by Leon, and he mentioned it's like Taylor University's astronomy club or something, right?
Yes.
Yes.
So,
hi. Yes.
Hi. So basically, our Astronomical Society will be collaborating with an organization, a society in Taylor's called Taylor Speakers Corner. Well, so yeah, Mr. Dorian is you can say the admin under Taylor Speakers Corner. So yeah.
Okay.
So hi, I run the space where we encourage people to speak and also to to hear about things that they may not hear elsewhere. So I think that I feel like this topic is very interesting. I love looking at stars as well. What you talked about, like the landscape of the stars, that's exactly the kind of astrophotography I'm interested in as well. And also deep space. Like I love a good nebula, like anyone. So yeah, but yeah, also like but also the fact that this topic, when Chris told me about this topic, I was really fascinated and absolutely interested to run this at the Taylor Speakers Corner. And we also have quite a number of people. I mean, not quite a number of people because it's exams and assignments time. So, but we do have still people joining us. So, yeah. So it would
Okay.
be very interesting. I mean, the fact that you're here knowing so much is also interesting because the people here would probably have never heard of astrophotography before. So pretty cool stuff. Pretty cool stuff.
Okay. Yeah, I'll share what I know, and I won't say I know much. There are many very very good star photographers. I'm playing. Uh, I have some experience, so I'm just
Mm,
happy to share those. Yeah, and I
yeah.
like your background, by the way. Wonders of astrophotography with the. It's pretty
Yeah.
cool. Yeah, I just thought, wow, okay, that's kind of
Yeah.
fun
The
looking
poster for
background with it.
today's event. Yeah.
Yes. Okay. So, is there supposed to be a panel discussion or talk or something about astronomy
So
first?
now it will be sort of like an informal talk. So everyone can talk about like what they like. Let's say what's their favorite image of sky image, or what's their favorite image, or what do they know about astrophotography.
Ah, okay. Okay.
So,
I have a quick question because um, I'm trying to do something here. Is it okay if I log in with two? I'm using my iPad, but I want to use my phone to log in as well, so I can kind of coordinate the two. Okay, so
sure.
I'm just gonna
That's fine.
connect with my phone too, and yeah, it's nothing. It's nothing special or anything. Just uh, easier for me to switch between
Yeah,
some
yeah, yeah.
photos that I may want to show, and also like talking in general and showing some
Sure.
stuff that I have, some
Yeah.
of my toys.
Nice.
Okay, so let me try and connect on Zoom here. Oh no, I shouldn't do this. Yeah,
I'm
I'm not
having
very
some
good with
difficulty.
I'm not very good with Zoom. I don't really use Zoom for my teaching, but okay,
Ah,
let's
okay.
try this. Yeah, I record videos on YouTube, and that's okay. Let's see.
Sorry, Derek. If you could just give me a second, yeah. Chris, I'm having some problem with the Facebook live stream. I don't know why. I've tried 3 times already. It's not letting me like stream.
What's
But
the
but the
what's the
thing
problem?
is, I need to make you an admin of Taylor Speakers Corner if you are going to do it.
I'm not
Yeah, I will
I'm
make you temporary admin lah.
I mean like I'm not well versed with Facebook Live either.
I will guide you. I had to learn this the hard way as well. Like, help me out here. Wait. Actually, you know what? Let me try something. Hold on.
Okay.
No, wait. Stop live stream. Want to do live on YouTube, but I haven't started a YouTube channel yet. CMCOB. Oh man.
So for the others, do you guys actually know what's astrophotography first? Like others? So
Hi everyone.
astrophotography is
Yeah.
basically just taking pictures of celestial objects. So it can be stars, it can be galaxies, Milky Way. So a lot of the science of astronomy and astrophysics starts as astrophotography. So, like, if you guys know about the famous black hole, image, do you guys know the donut? So yeah, so astrophotography is pretty important. But it's also a fun hobby. Some people, they started out with their eyes, and 3 weeks later they have 10 telescopes if they are rich enough. I think Mr. Derrick would know. So yeah, for some people it may be an expensive hobby, but what I would like to share is that you do not need expensive equipment to start off astrophotography. Like some people can take fabulous pictures with their mobile phones. So yeah, anyone can start astrophotography, right?
That's correct. If I may just add. So I've never done one of these before. I'm just gonna switch into talk, right? Okay. So yes, what Qi mentioned is very important. Astrophotography is, and I mean, this goes already partly into my talk. It's about science and art. So the science part is collecting data. And how do you collect data? You collect light, what you see in the sky, okay, in the stars. And how do you do that? You use a camera, like this thing here. Okay, so now you can get a digital camera for like probably some people less than well, maybe 1,000 ringgit or so ish, and then another lens probably below 2,000 ringgit. You can get a setup that you can use for star photography, and literally you are capturing data of the sky because you are gathering the light from the sky that it is. You got to remember that the stars are how far away? 4.3 light years, 4.2 light years away is the closest star, means that the light that went to your camera took 4.2 years to get there, to get into your camera, maybe a little bit longer. So anything that you photograph is actually very significant. And I think that not many people can appreciate this, but when you look at a photograph of the stars, you should be awestruck. You should be just looking and say, oh my God, this universe is so big, how far is that star? Look at how many are there, and we are just one tiny planet around one tiny star, and it's crazy to fathom, just wow. It blows your mind every time you see that, right? So yeah, and then that comes into the feeling part, and that's kind of where it instills the art, right? Now you start to pardon. Sorry if there's some background noise. It's my neighbors. I'll try to get out of it. But let me just put it this way. When you try to combine the feeling, okay, that you get with the data that you see, that is where art comes in, right? And some people try to put an expression in it. Maybe make the sky a little bit blue to kind of be cool, look cooler and calmer and peaceful. Some people want a very dynamic looking sky, so they kind of use a ultra wide angle lens with a lot of this, angular distortion that kind of makes a very, very deep in feel. Yeah, wow. So when you look at these photos, it just gives you like a wow feel, or maybe a very calm feel. I'm kind of a more calm feel person, but when I see a wow photo, I still go wow. Okay, yeah, and true. If you really like it, you can really spend a bit more money to get equipment. But I'm going to show you actually shortly how little equipment is necessary and how little you have to do. Okay, and if you still, you're listening to me like, nah, I want to do something crazy. Yeah, then Cress is your guy. He's gonna tell you all about buying all these expensive equipment, but they're very cool. Okay, and then what you do is already trending, towards hard science. Okay, what astronomers at observatories do to process their images, to try to get the data out. What did you capture in your camera? This light from tens of thousand light years to a million light years away. Well, tens of thousand. I think there'll be probably about our limit with the camera. I'm not a deep sky guy, so I don't know how dim a galaxy can we get. Quasar. I think people have photographed quasars, which are quasi-stellar objects that are. How far are they? I don't have the number at the top of my head. They're like freaking
they
far.
can be from billions of light years. They can
billions.
Yeah.
Okay.
Yeah.
Wow.
So
okay.
in fact, the furthest like one quasar, I can't really remember. It's about 2.6 billion light years.
Wow. Okay. What's the closest one is called 3C273, right? I think
like
it's in 3C273.
Okay.
I can't remember how far that is though. But,
okay, for other people, you might hear all these 3C273, NGC2244, all these weird names.
The names of the stars.
So yeah, later both Derrick and Cress would be talking about all those, and they are basically catalogs for how we categorize and catalog celestial objects. So one of the most, I would say, popular ones is the Messier list. So to put it simply, Charles Messier, a French astronomer, was trying to find a comet, like Neowise, if you guys know. And then he saw some objects that he thought was comets, but in the end, he was very, very disappointed. So he decided to make this list as a blacklist for comets. So basically this blacklist eventually became one of the most widely used catalogs for celestial objects. So yeah. So later during the talk, they will be telling you about all these stuff. You guys don't have to worry about it. So yeah. So
also, if you don't know what a quasar is, it is really very cool actually. It is basically like the center of a black hole that's eating something. So it makes it very bright because it's currently consuming the middle of a galaxy or a star. And so like the streams, like the jet streams you can see from like billions of light. That's the only reason why we can see it from billions of light years away, because it's that bright. Our sun would not make an impact in the night sky to a person 2.6 billion light years away. Like,
yeah. That's true. So this is why sometimes for me, when you look at the night sky, you will think that you have a lot of impact towards the world, the universe, but you're just a small speck. Like I think Carl Sagan said that we are once part of. We are
The
basically a
pale blue
stardust.
dot.
Yeah, we are just a pale blue dot.
Yes.
Yeah, so basically, sometimes it's really awe-inspiring, and yeah, this is why I like astronomy, because it makes you feel like yeah, not to be too sad at this point, but we don't have a really large impact on the world. This is why I want to learn about the world. So yeah. For Shim, okay, let's say Shim Ji Jun. Do you have your favorite photo of the night sky, or what is your favorite celestial object? Mm. Yeah, that's true. Like in 1980 something, New York had a blackout, and then at night. So when everyone went out of their building, they saw a fuzzy thing outside on the sky, and they actually called the police because they thought that it was aliens. But they are actually looking at the Milky Way. So yeah, I would say I would say basically the advancement of technology, like let's say light and all those, also made us disconnected from the night sky. Yeah, I think it's a sad thing. Light pollution is a thing, and Mr. Derrick is also an advocate of reducing light pollution. So yeah.
Can I
WK.
share? Can I
Yeah.
share something?
Yes.
So all I've ever known of the night sky is basically what's available here in Malaysia, right? And basically like sometimes you go to Cameron Highlands and it's one of those really cold nights where there are no like clouds, and then you see like a lot of stars. And so I was always like very fascinated by stars, and like like pointing out like each one that you can find. But there was one time I had the chance to go to Nepal, and I went to this place called Nagarkot, and it's basically like this hill station that is right before it is facing the Himalayas lah. So it's quite uh a hilly place. It's not like a mountain, but okay. So anyway, so we went up there by jeep and all of that stuff, and when we got out it was already night, and it was so cold, but we just couldn't move because it was just all stars. Like there was no like, it was just stars, and I had never seen that before. Like, because there was so much light pollution, and I never like realized how bad it is here, but there was no light at all. So it was just stars everywhere, and you could see like the shape of like, you know and it was just beautiful. Like my friends and I, we just stood stock still and just stared at the sky. It was an amazing experience.
Yeah.
That sorry. I mean, I just want to add because similar, when I was in the States in Arizona, there's a spot between Phoenix and Los Angeles, kind of right near the border between California and Arizona. We drove there, pitch black. Couldn't see our hands when we got out of the car. Couldn't see the ground. But after that, eyes adjusted. Okay, yeah, we can see. And then okay, good. And then we start seeing a shadow under the car. What casted the shadow? Anyone want to guess?
The Milky Way?
Yes, the Milky Way cast a shadow. And it was just mind-blowing, okay? I mean, I wasn't into photography back then, unfortunately. Otherwise, I would have taken a photo. I would have just taken the photo of the Milky Way above car there, and then there's a shadow. But I think there's a question on the chat, right? Someone's asking, where in Nepal? Probably question for Dorian.
Mr. Dorian, where in Nepal?
Nagarkot. So I'll just spell it in the comments, the chat.
Cool. Cress, do you have a favorite celestial object? Wait, is Cress here?
Hey, Jizong, how are you?
Yeah.
Sorry, I'm still having my dinner, so I was just listening without trying to not to make a noise.
Okay, cool.
So you were asking favorite celestial object?
Yeah.
Probably galaxies. It's definitely galaxies. And if you want me to pick a favorite one, naked eye, we can only see the M31, which is the Andromeda, and probably M33, the Triangulum. But if you're talking about photographable object, my favorite would be M51, the Whirlpool Galaxy.
Yeah,
that's majestic.
Yeah, it is very majestic.
Yeah, I wish I could show you a picture right now, but the pictures are all in my laptop.
Okay.
When I'm ready, probably I'll show you guys.
Okay, sure. So yeah, basically, there are countless objects that are actually really beautiful in the night sky. So at times, at least for me, I would just lay down on the grass and just look at the night sky and just not do anything because it is very beautiful. So yeah.
Chris,
yeah?
Sorry, I probably have to restart my computer because it's not working at all. But you are co-host, so it should be fine. Just make me host again when I come back, lah.
Okay, sure, no problem.
Okay.
The feedback. Before that, so I don't know if you guys know about the Jupiter at opposition. It's just a few days ago. So it basically means that Jupiter is the closest to us, and so it's the brightest. So yeah. So on 20th of July, Saturn would be at opposition. So basically it would be brightest. If you have a telescope, you might even be able to see the rings. Yeah. So, okay. Before the talk starts, I think you guys can raise hand, is it? Or whatever. How many of you guys have done astrophotography before? Or have tried to do astrophotography before?
Or how many of you have tried to take a picture of the night sky? Me.
Oh, wait, before that, I will make you the host.
No, don't yet. I'm still on my phone
Oh, really?
because
Oh,
my
okay.
laptop had to update. Yeah.
Okay. So yeah, WK Gore, what was your experience on astrophotography? Wait, are you there?
Maybe he's typing.
Yeah. Okay, like let's say Tan Hanjet, what was your experience with okay. Okay, Shim. What was your experience on astrophotography? So yeah, for those who don't know, Taylor's Astronomical Society has brought a few people, me included, to Tanjung Piai, which is the southernmost point of the Asian continent and the southernmost point of Malaysia, to experience basically the annular solar eclipse. It was a great experience. So yeah, did anyone see the solar eclipse last year?
Yeah, I saw from Utah. From Utah, from uni.
So
The
yeah,
clouds were so thorough.
well, yeah. One thing about astrophotography in Malaysia is that the weather is very unpredictable. So 1 hour you might have clear skies. The next hour you might have cloudy skies or whatever. Both Derrick and Cress would know the feeling of finish setting up the telescope just for it to be cloudy and yeah. So, but one good thing about being in Malaysia is that we get to see almost the entire night sky. So if you are at let's say the United Kingdom, yeah, the weather in Malaysia is pretty predictable. It's always cloudy. Yeah. So if you're in the United Kingdom, you would not be able to see some of the objects in the southern hemisphere, and same goes with the southern hemisphere as well. So yeah, okay, I think it's time. It's time to start the talk. So for those who have just joined, welcome to the.
Sorry, Chris. Give me a second. Let me just get back and put it on Facebook first. I'm so sorry to the speakers here. We're having some technical difficulties.
Okay. Okay, for now, we'll just wait for a moment. On behalf of Taylor Speakers Corner, we would like to apologize for the technical issues. We'll be starting the talk shortly.
Don't you have that screen? Ranjangan Tegendala, harap maaf.
I know, right? I should get that.
Background music.
Yeah. Especially with like online stuff, you never know when the internet will just be terrible, or when the connection is just not happening, or when your laptop suddenly needs to update itself.
Yeah, it is. I mean, before that, how's COVID-19 for you guys? Was it okay? Not okay? How's COVID-19 in general?
I actually had a question I wanted to ask this lah, but did COVID-19 and the lockdown, did it change the night sky at all? Like in terms of photography, like astrophotography?
One positive thing about the lockdown around the world is that studies have shown that it actually decreased the air pollution. So the sky actually became clearer, especially if you see at the at China, the air pollution is markedly decreased. So if we were to go to China, the sky will actually be clearer. And yeah, but hopefully the sky can continue to be clearer. I mean, the Industrial Revolution has brought upon air pollution. So yeah. So
It's true.
yeah. Mr. Dorian, are you still is the laptop still there?
Yeah, it started already. I'm just logging in now. I'm trying to
Okay.
get the meeting code from my
Okay.
WhatsApp.
Okay. Yes. Cress, do you want to answer that? Mr. Derrick? Because I'm a
Sure.
a night owl.
I can help. Actually, the easiest way to do it is go download an app, an astronomy app, planetarium app. Okay, or if you like, I recommend one app called oh gosh, what's it called? I skipped my mind. Sky Safari. Okay, so Sky Safari you do have to purchase, I believe, but it's worth it. It's few ringgit, okay, but just pretend you're buying an astronomy book, right? So click in Comet Neowise, and then you can find its location. So I did try that, and you can set the date, you can set your location. So I set my date to July 18th, and then my location to, I believe, was Penang. Probably should have done Kuala Lumpur, but July 18th, it should appear about 7 degrees or just about a fist width or more above the horizon after the sun sets. It will be at the paws of Ursa Major, the big bear in the sky. So now I think a lot of people are apa tu lah, big bear apa. So it's a constellation. And if you have the app, which again, this is why I encourage you to purchase it, because with the app, you can really see, you can use the compass mode, and then you can just pan around, see. I mean, I think there are other apps that can do that too, but I'm not so certain about the accessibility of the comet data, okay? Because every time we discover a comet, we need to enter something called the ephemeris, meaning that the orbital parameters, how the comet goes around the sun, how is it angled, how fast is it going, blah, blah, blah. Okay, those are stuff for Qi Zhong to do, right? Are you studying astronomy? I forget. But anyways, yeah, once you enter it, the planetarium software will calculate and then it'll project the position of the comet, right, in the sky. And so, you know, I think that for Malaysia today may not be ideal yet. I believe it's about 4 to 5 degrees above the horizon. I mean, it's possible if you go up on a tall condominium that's facing northwest, ideally. It's very bright, so if you just aim a camera there, you could probably capture it. Yeah.
Okay, Mr. Doran, so should we start now? Okay, so now the talk will begin. So basically today there will be two speakers. One would be Mr. Derrick. So as he has mentioned before, he has been an amateur astronomer for almost 30 years and an astrophotographer for near 6 years, right? 6 years. So he would, in fact, Mr. Derrick has a photo that is featured in the NASA's astronomy picture of the day, isn't it? So yeah, it is one of the, so it is a really cool feature. So yeah, so he would have the extensive experience and knowledge to talk about this topic. So let's welcome Mr. Derrick.
Thank you. Thank you very much. Yes, so I think let me just start off by saying that thank you very much to the organizers for inviting me to give this talk and share my knowledge. Okay, so initially I had the impression that Zoom could share my screen, but I couldn't find any options on the iPad. Okay, so I had actually some photos and presentation a bit to share, but that's okay. I'll just talk based on my presentation notes, okay? So I would like to be, I'm supposed to be talking about starscapes and wide field star photography, okay? So, but let me just start off by saying, you know, kind of like describing what in general is astrophotography. So it's kind of a repeat of about what we talked about probably 45 minutes ago, but let's rehash it, go into it again to kind of get a deeper understanding. So I think astrophotography is one of the most fascinating forms of photography. Why? Because apart from like birds, nature, wildlife, and stuff, it is basically where science and art collides, meet, marry, argue. It's like a marriage. Okay, so I think that for one, okay, astrophotography represents a science because it's astronomy, and then the photography part is the art. Now, astronomy is a science about the stars. So when we take a photo of the stars with a landscape or just the star itself, we can consider that as astrophotography. Okay, and what we really are doing in astrophotography is collecting data from the night sky. Okay, basically, if you say that, okay, I love the Milky Way, as someone mentioned earlier. Yes, so if you took a picture of the Milky Way, what you did was you captured light from the Milky Way galaxy, probably up to thousands of light years, right? I forget, I'm sorry. I don't have the numbers out of my head, but about thousands of light years. And feel free to correct me, anyone, if you know how far the galactic core is from us. But just imagine that the light that your camera captured and you display on the screen came from a star that emitted it thousands of years ago. So it's mind-blowing, right? And you are capturing what the Milky Way galaxy looks like 10,000 years ago, or however long the light took to travel to our eyes. Okay, and there are other stars, of course, that are much closer, as close as 4.2 light years, etc. So that is the science part of astronomy. Okay, so before you go to sleep, because it's science, okay, let's start the art. So the art is, all right, I got the photo of the Milky Way. Now I want to make it look brighter, okay, more contrasty, okay, and prettier. Put up the saturation, so some regions have nicer colors. And that is what we call image processing, which to most degrees is okay to our taste, right? As long as we're not adding stuff to it or removing stuff from it, right? Like if you say, oh, I don't like that star over there, it makes that triangle looks crooked. I'm just gonna remove that star now. Okay, some people might not like that, okay, especially hardcore astronomers or some even, astrophotography enthusiasts, okay? So you might want to watch out for that. Even there's a recent incident of comet Neowise that a tail structure was photographed, okay? And it turns out, according to the guy that processed the image, it was noise that he accidentally enhanced and made look nice. And so that structure wasn't real, but he posted it, and it's even in a Facebook page called Sky, okay? So that's the Facebook page called Sky, SKY. I encourage you all to, subscribe to it because, or just like it, because it's actually the astronomy picture of the day page where they select some of the better images, okay, that were submitted for astronomy picture of the day by NASA. Okay, so are there any questions so far? Okay, once we get some of this stuff out of the way, let us start. Okay, talking a little bit more about astrophotos. Now, I'm very unfortunate I cannot share my slide. I have a slide where I kind of am showing off. Okay, so what astrophotography is, okay? What types of astrophotos are there? There's, well, for me, the categorization. Yes,
Derrick, I'm so sorry for interrupting, but do you want to
no worries.
send the slides maybe to Chris, so that he can
Maybe
put it, he
you
can
can
share
send
it
it
for
to me.
you? Yeah.
I can send it later, right? Okay, yeah, I can send it later. I mean,
So that he can share it on the screen for you, so that you can talk while we can see the slides.
Can I share it on the screen at all? I haven't figured out how to do that on the. Oh, I could share content. Oh yeah, okay. Share screen. Okay. Hold on a second. Oh no, that's screen recording. Yeah, I apologize. I'm not very good with Zoom, so.
No, it's fine. It's fine. What I meant to say was to email the slides to Chris so that he can put it up from his screen. But I think that's fine. I think you can just go ahead with.
Yeah. Okay. Yeah, because the slides are a bit. After I saw how the platform works, I think that maybe I'll refine it and then I'll send it. Okay.
Okay.
Yeah, but let me get back to the topic. Okay, so what type of astrophotos are there? There'll be starscapes, which are stars and landscapes, which the popular Milky Way with a mountain or the seaside or something, and then there's star fields, which are basically just parts of the night sky. Okay, and well, probably zoomed in. Okay, and then there's the deep sky part, which Cress will be talking about. And then there's also planetary. So what I was trying to show off was I have all categories of photos using my equipment. Sorry, Cress. I just think that I like to go simple, all right? But I mean, of course, there will be, for deep sky imaging, there are two types. One is my type, lazy, just slap together photos, stack them, and then, you know, edit them a bit and then kick them out. But there's also the more nuanced approach of deep sky astrophotography with narrow bands and stuff like that. Okay, I'll let Cress talk about it. Okay, but for most of us, what's the basic setup? Okay, I'll try to take you all with me outside. Okay, I actually prepared everything, and I didn't realize my neighbor has a resort, and he maybe you guys can't see either. I have to. Okay, my neighbor has a resort, and the neighbors, I mean, there are people staying there, so they're a bit noisy. So let me grab my stuff. This guy. So this is what you need. Number one, a camera, okay, and number two, a lens. Okay, so let's separate the camera and the lens. Two things are we talk about separately. Okay, and then we need one more thing, and that is this guy right here, a tripod. Okay, a steady tripod, a stable tripod. So the advice is don't go out and buy that cheapest tripod that you can find, because if you bought a cheap tripod, first of all, it's not steady, your equipment might fall. Second of all, if the wind starts to blow, not a very strong breeze could cause a cheap tripod to kind of vibrate, okay, because it's made of plastic and it's too light. So once the wind blows, your tripod starts to shake and your stars, the image will start to look messy. So please don't save on the tripod if possible. Now there are lots of cheap tripods available now on like online, okay, like Taobao and Lazada. Yeah, a lot of these suppliers. So I encourage you to go do your research. Aluminum tripods are probably best. Some people say, no, I prefer carbon fiber because it's lighter. Of course, it's more expensive, but it's cool, carbon fiber. Carbon fiber is lighter, but of course, lighter means less steadiness. So this tripod, I can tell you, it wasn't too expensive, if I'm not mistaken. I bought this. It's a Manfrotto. I believe it was about 100-ish USD. I bought it in 1997, and here it is now in 2020, still stuck with me, still working. Okay, I think I dropped it countless times. Probably kicked it a few times too, out of frustration. Not encouraged, but anyways, that's what a good tripod can do for you. Stay with you, work for you for a long time. Okay, so let's talk about the camera first. So here, what I want to start off with saying is that today's technology is so good that pretty much any camera is okay. You know, there's the argument like, oh, micro four thirds is no good, or full frame is too heavy, you know, blah, blah, blah. Yes, they're all true, but it doesn't deter you from taking a photo of the stars. Nothing will, okay? If it's too heavy, buy a studio tripod. If it's, so the argument against micro four thirds is it has a small sensor, but a sensor in a cell phone can take the Milky Way as well and the stars. So size doesn't really matter until micro four thirds. Okay, below that for cameras, yes, it's a bit more challenging. Okay, and the reason for this is I just explained briefly. The larger your sensor, the more light you can collect to form the image. If you have a smaller sensor but the same image, okay, same field of view, literally your smaller sensor has to be blown up more. When you blow it up more, it's like you have two swimming pools. Okay, a large swimming pool representing a large sensor. They have the same depth, of course, say 1 meter. Okay, but one swimming pool is larger, and the other swimming pool sensor is smaller. Okay, and then you have to spread the water out into the same area, same size area as like a photo, let's say a 4x6 print, or maybe larger, 8x10. Okay, so the water in the smaller swimming pool would have to spread more than the one in the larger swimming pool, right? So the water gets shallower. And then inside the swimming pool, there are these rocks, which represent noise. Now, if you spread the water out too much, more of these rocks will appear, right, out of the water. And that tells you that for a smaller swimming pool, there'll be more noise in your image, okay? But for a larger swimming pool, there'll be less noise. Now, I've seen arguments about this, about, you know, and pardon me if this is getting too technical, but I just like to address this for some who are more, you know, more curious about the technology. Some of you may know about, pixels. What about the pixels? The size of the pixels too, right? That is correct. Now, the size of a pixel doesn't really matter in the whole scheme of things, okay? Except for one thing, how deep that pixel is, how much light or how much water it can collect. Now, if you have the same pixel, same type of pixel in the full frame camera and the Micro Four Thirds, the argument is moot. You have the same kind of sensor, your swimming pool, your pool of water is the same depth. And again, it boils down to the size of your pool and how and how much each have to spread to the same size to form the full image. Okay, so if you're not very clear about that, you know, you can raise your hand to ask further questions, or you know, I don't know, we can talk about it further via chat or something. Okay, so but in my slides I do share a photo that I took. I'm gonna see whether I can get a good angle. Okay, probably like that. Okay, so you can see that this photo has the full extent of the Milky Way, with actually my friend. I don't know whether you can see him right there, but he's tiny, standing right there. It's to me quite a nice photo. I like it, at least, and it's taken with an Olympus camera, which is a Micro Four Thirds system. Okay, so nothing will deter you from taking a good photo, or a photo that you like. Okay. So, but we know that the camera, you know, okay, any camera can take. It's just there's a give or take for the sensor size and stuff like that. Okay, yes, true. So that's kind of not important, right? So what's more important? Yes, here he comes. This guy. This is the lens. Okay, this is a lens. Now, there's a reason I bought this lens. It's not very expensive. It's a Samyang 24mm f1.4. So what does 24mm mean? 24 millimeters means the focal length of the lens, okay? But more importantly, what 24 millimeters defines is how wide your field is, okay? Now, your iPhone, I believe, is 28 millimeters, which is a bit narrower than 24. 35 is narrow, 35 millimeter will be yet narrower, 50 millimeters will be even narrower, and of course, wide angle. Some people love 14 millimeters, okay, very wide. And why? Because it's so wide, it's so big, you can see the whole Milky Way, you can see the sea, you can see the sand, you can see everything, you know. It's like, it's expansive, it's huge. The sky is huge, the ground is huge, everything is so big, and it's a wow. Okay, so a lot of times people like to use wide angle lens to compose. Okay, for me, I like to operate around 24 to probably 17, 16 millimeters max, because what I find is for very wide angles like 14 millimeters, or once I use a 12 millimeter f2.8, wow, it was a bit too wide because I'm having too many things in a photo and I don't know what am I trying to take. Okay, is the Milky Way the movie star, the star of the photo, or is it that mountain far away, or is it the lake, you know, or is it that cow over there, or is it the car that's parked over there, or is it everything, the car, the cow, the person, the sky, the mountain. And when you look at that kind of photo, you're going to get a headache. You say, oh yeah, it's very nice, but oh, I don't know, what are you trying to tell here, right? Okay, so the wider angle lens are harder to use. Okay, so a little bit about the terminology, right? Aperture. Okay, I think you can see this. Yes, well, sort of. Let me try to align it with. So I'm closing the aperture. This is a small aperture. This is a large aperture, but it's like the golf par score. So here I'm at f1.4. Okay, f2.8 is a bit smaller. Maybe you can see that. f2.8, just a little bit smaller. Yep, there's 2.8 right there. And now I'm gonna make it smaller all the way to f22. So that's called aperture, right? So aperture controls how much light comes in through your lens. Now, for the stars, what apertures do you think are the best? Of course, f1.4, if you can, open it wide, right? So because the stars are so dim, the wider you open, the more light comes in. And then, yes. But there's a problem. When lenses are open this wide, all the problems at the edges of the lens combine to form your image. And the problems will show, okay? Meaning that when you use, let's say f1.4 in this lens, actually this is a very good lens and it's cheap, is, I forgot, below, if I'm not mistaken, it was below 1,000 ringgit or just above 1,000. I forget. It's cheap for a lens. Okay, let's just put it at that. Okay, but if you're at f1.5, all the problems in the lens will manifest itself in your image. The edges, they are not sharp. Okay, it's very hard to make lens all perfectly sharp, a beautiful picture, all very nice in the in your photo. Yeah, I just saw the chat. Yeah, they are so expensive. Buy secondhand if you can. You know, a lot of people, they buy this lens and then they see the other sexy, beautiful new lens, you know, that has autofocus, image stabilization and everything. They say, I don't want this Samyang anymore. I said, oh, sure, throw it to me. My buddy Cress is like very good at that. Okay, so anyway, sorry, Cress.
Come on, Derrick.
I know, I knew. Okay, anyways, yeah, well, get secondhand stuff. It's cheaper. I believe this is like few hundred for secondhand. So here, secondhand, a few hundred, and then a camera body for 1,000-ish. So like I say, below, well, and then plus a sturdy tripod, few hundred ringgit. I think below 2,000 ringgit. Yeah, you can take decent astrophotos. Where was I? Okay, so what we do, okay, f1.4, not great, we stop down a little bit, let's say to f2 or f2.8. Okay, just a little bit. Okay, sometimes I stop down to f4. Okay, and I tell you when. Normally when I take star fields, okay, photos of only the sky. Okay, parts of the sky, constellations, for example, or the Big Dipper asterisms, which are kind of like star groupings, like the Big Dipper. In Chinese is 北斗七星. In Malay, what's it called? I'm very sorry.
I can't remember too.
Apa tu? Melayu.
I've forgotten too.
We must learn it. Okay, we must learn it. Well, I need to learn it. I will find out. If anyone knows, please share it. Thank you. I really like to know it. So anyways, sorry. When I stop down to about f4 to f5.6, that's when I do that when I take starscapes. Sorry, not starscapes, star fields. Okay, so portions of the sky. All right. So I think that this kind of pretty much covers the basics of astrophotography. Camera, lens, and a sturdy tripod. Put them together, stick them somewhere, look at the stars, and then aim, take a photo. Okay. Anyone see a problem there? Okay, how to focus? Because your lens need to focus, right? And normally, they see there's a scale on this lens right here, right? And so we can just adjust the scale. Oh, where's infinity, right? The stars are at infinity, so that's at infinity. I'm sorry, it's upside down. Okay, there we go. That's at infinity, right? Well, sometimes the infinity stops are not correct. So what we can do is, and what I usually do is on your camera. So here I'm using a full frame camera, and a Canon EOS R, which actually is surprisingly good for astrophotography. And what you do is, through the lens, you find a bright star, okay, or something very far away, like street light, at least about, I usually just say as far as possible. But if you don't have any light at all, any points, small points of light, I think if you have a 24 millimeter lens, I would focus about 100 meters away at least, okay? Probably overkill, but just to be safe, because you definitely want to have your stars as pinpoints. So focus on an object about 100 meters away, at least, for 24 millimeters. For a wider lens, you can, it can be a little closer, but you know, let's just put the limit at about 100 meters or far away. So like when I went to the seaside once in Malaysia, most popular thing at the seaside, kapau sotong. So I use the lampu sotong lah. Just look and then just focus on the lampu sotong, and then okay, perfect. I'm pretty sure they're about 1 kilometer out, and aim it at the sky, at the stars, boom, focus, perfect. Okay, that's good. So otherwise, what you can also do is, if you have a star app, star planetarium app, okay, any app would do in this case. You can look for the planet Jupiter or Venus or very bright star, Sirius, Arcturus or something, or you just see some bright star there, take out your camera and just aim it at that star, try to. Okay, now this is where knowledge of the night sky comes in, right? So there is a learning curve, okay? You have to learn about the night sky, but let's say that, for example, you were able to find Venus. The planet Venus, very bright, is the brightest object after the sun and the moon in the sky. Right now it's in the morning. You can see the morning, in the morning before the sunrise, the morning star. Okay, aim at Venus and then focus. On your camera, you can zoom in. I have this, there's a zoom button right at this corner right here. I don't know whether you can see it, but there's a magnifying glass below it. And I just click that, and then on the screen, I can see a zoomed in view of the star. And then I rotate the focus until the star becomes the smallest pinpoint, okay? Smallest point. And then that's it. I let go, then turn off the magnification, and then I know I'm focused perfectly on the stars. Okay. And then now we have to go to exposure time. So with exposure time, it's tricky. If you only have, now I said only, so more stuff to buy. Yes. Okay, but let's go to the basics first. All right, if you only have a camera, a lens, and a tripod, how long can you expose the stars? Okay. Oh, easy, right? It should be as long as you can. Well, there are some problems with that answer. Number one, okay, the simpler reason is light pollution. If you have light pollution in your area and you expose for too long, your whole photo will turn white. You're basically taking a picture of the light that shine in the sky and scatter back, reflect back into your camera. So that's unfortunate. Okay, so if you are taking photos from a light polluted area, you're limited by the light pollution. So I probably won't go into a deeper method of determining, okay, how much your exposure be. But in light polluted areas, we are kind of limited. We want the background to be as dark as possible and the stars to be as bright as possible. So think about it this way. Your stars, okay, are just spikes on your image, okay? And if the sky is dark, okay, the ground is at 0, right? And then the stars are like spikes coming out. When you have light pollution, this ground is now not at 0, but your stars remain the same height. So the ground goes up. So now your star is only this high relative to the ground. meaning that you lost what we call image contrast. Your stars are not as, punchy as if the background sky were black. Okay, so you lost that amount of contrast right there. So now your stars are, instead of being like that high, it's just that high above the background background light. Now if you expose so much, okay, your stars are gonna reach the maximum in the sensor, and then your light pollution comes into the maximum of the sensor too, and then now you cannot see anything, any difference between the star and the light pollution, the light background, that ugly light. And so of course, ideally, what you want to do is, if this is how high your star is, and then this is your light pollution, you want to expose so that you get this height as clear as possible. So you can expose so that the sky is not pitch black, a little bit bright, but you can see the stars. It's not a bit bright, but just like kind of starting to shine through. Okay, so that way you still have the contrast of the stars. Okay. The second problem, okay, with opening the shutter for a long time, and this one here is due to our Earth itself. Our Earth rotates, and as our Earth rotates, the sun rises and the sun sets, the moon rises and the moon sets, the stars rise and the stars set. What? They do? Yes, they do. Okay, so, well, some of you maybe already know, but the star, the moon, the sun actually are all kind of like on this sphere in the sky, and we're inside the sphere. So we're looking at the inside surface of the sphere, okay, and then all the stars are stuck on it, and then the sun and the moon, and then they're moving along with the stars, okay? Or you can say that, well, the sun and the moon, well, when they're moving, is because the earth is moving, blah, 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 blah. Okay, all the science, all the physics. Let's stop that. Easy way to understand it, there's this sphere, okay, which is the sky, and then we look up, the sun and moon are stuck to it, and then it kind of turns. Okay, so the sun will set, the moon will set, and then the stars do rise, and then the stars do set. Okay, so this motion, of course, 24 hours is 360 degrees. So the star does move at a certain speed across the sky. And there's something called the 500 rule. Okay, so take 500, divide by the focal length of your lens. So full frame is easy. Just read the number there. What's that? That's a 24. Okay, 24 mm. If I'm zoomed in a bit, okay, I think that's 50 millimeters right there. Okay, so 50 millimeters, I take 500, divide 50 millimeters, okay? How many, what's the answer? That's 10, right? So 10 seconds is the longest I can expose using this 500 rule. Okay, there's a more complicated NPF rule, I won't talk about it, because the 500 rule is pretty good. Now, it's also more complicated than that. Stars at the celestial equator move faster than the stars at near the north celestial pole, near Polaris. Okay, but again, I won't go into that because it's a little bit more technical detail, and if I start to describe it online here without any props, it's not going to be easy. So just leave it at the 500 rule. 500 divide by your focal length. Now, if you don't have a full frame camera, you have a crop sensor, say micro four thirds. And you say, but Derrick, 50 millimeters, and on my Olympus, it's going to be 50 times the crop factor of 2. So it'll be 100 millimeters field of view. Which one do I use? I use 50 or 100? Now, since your field of view is 100, you take 500, divide 100. Okay? So you have to include the crop factor. Okay? Mainly is the field of view. That is kind of like the key factor for how long you can expose. But let me just tell you one thing. The stars are tiny pinpoints on your image, and 500 divided by the lens focal length, or the 500 rule, is, I don't like it to call it the rule, is actually a guideline, 500 guideline, meaning that it's just a guide. There are astrophotographers that expose a little bit longer. Okay, I've done. So if 500, you took 500 divide 24, I believe it's about 20-ish seconds. Okay, but I just went ahead and do a 30-second exposure. The stars trail a little bit. Some people hate that. Oh my God, your stars are trailing. So what? Okay, I like it. You know, because when I zoom out and then I see the whole picture, wow, that Milky Way is just a little brighter than if I did 20 seconds. Okay, so I mean, I got more signal, right? I got more star information with the longer exposure. So it's kind of like a trade-off. Some people hate that star, that little supposed to be pinpoint dot, mathematical dot. It's trailed a little bit. It's a tiny short line. They hate it. You know, when I zoom in, oh my God, I see a line. Some people hate it, but some people are okay with it. Some people are cool with it. I'm cool with it. You know, I personally think that, oh, it's all right. You know, I mean, just look at the overall image. Wow, look at that. There's that lake, and then there's the Milky Way above it, and then there's some reflection. Okay, beautiful. I love it. And zoom in. Oh, the stars are trailed a bit. That's fine. Not a big deal. Okay, so just take your personal preference. No right, no wrong. Please don't argue over it on the internet. Okay, there are too many of these kind of arguments. Okay, so 500 rule, exposure, time, okay. And then remember to stop down your lens a little bit. But when you stop down, remember, when we stop down our lens or close the aperture, okay, close the aperture down a bit. When you do that, you let in less light. So I also did this. I said, yeah, I know the image is not perfect at 1.4, but I'm doing 1.4 anyways. So I just did 1.4 and I blew out the image. The whole image was white. So, okay, well, it's a good problem to have. Now I can stop down happily and say, hey, this is bright enough. Okay. Next, let me talk about a little bit about photo editing. Okay. Unfortunately, it's also very hard to kind of like do a demo of like how do I edit the photos. But I just share what I do. Okay. I will capture the image using the raw files. Okay. I don't use JPEG for star images. I take stars and birds. For birds, sometimes I use JPEG. It's okay. But most of the time, I still use RAW. Why? Because raw image files give us the bigger space to work with. We can pull the contrast, pull down the highlights, meaning the bright parts. We can pull it down. The dark part, we can make it brighter, you know. And you can get a good image out of, you know, almost meh image when you look at a camera. Oh yeah, this doesn't look nice at all. But put it in Lightroom or Photoshop. I use Lightroom, Adobe Lightroom. Okay, and I could adjust the sliders. I like the contrast slider. I like the dehaze slider, and I usually pull down the highlights a little bit. Okay, it depends on your taste. Okay, here's one little secret that maybe not many people know. Okay, if you pull down the clarity slider, don't pull it down too much. If you pull it down a little bit, you can make your stars look a little bit smaller. Why do you want to make your stars look a bit smaller? Because if you have bigger stars, sometimes it can look too grainy and your image look a bit cluttered. Okay, so you pull down the clarity slider, I think -20, -25, or sometimes I do -30, 35, even -40. My stars actually get smaller. And the image, you know, like I'm taking a Milky Way, my stars are smaller, but you get that Milky Way shape that is much more defined because the stars are now smaller and less distracting. Then, oh, okay, that's kind of nice. You know, but again, you have to play with it to your taste, to your feel, you know, how you feel that the image look the nicest. Okay, but that's kind of a little tip that I just share with you. Okay, the dehaze slider is very helpful in Malaysia because the weather is so wet. Well, in Thailand too, and the weather is so humid. You get some haze, some fog. There's a little bit. Your eye may not see it. You say, no, what are you talking about? The stars are so bright now. It makes the stars look a bit bigger, a bit hazier, fuzzier. You know, just use the dehaze and then try to bring out more detail. darken the background sky and then brighten the stars a bit, you know. But don't use dehaze too much, because when you push dehaze too much, you just blow the bright parts and then make the dark parts and the dimmer parts all black, and then it's just, your image just, okay, crashes. Okay, so how am I doing on time? What's the time now? Oh, 47, my goodness. How much time do I have?
Roughly 5 minutes.
5, okay. All right, I'll quickly talk about two things that are additional. So one is, some of you may already have a lens. I said, I have a 35 millimeter lens at home. Now you're telling me that I have to buy a 14 millimeters or 18 millimeter or 24. You know, no, I don't have that money. I said, well, that's okay. That's fine. What you can do is panorama stitching. So that wasn't good. Okay, sorry. I should have pulled my iPad with a keyboard. Okay, so here's a panorama of 3 images. I can see, yeah, I'm okay. I'm not sure about the iPad, but it seems okay. I might have to ask it. Are you okay, iPad? It seems all right. Okay, so sorry. Anyways, this photo of the Milky Way over in Mersing, okay, is a 3 panel, 1, 2, 3. Yeah. So three images combined to form a panorama with about 50% overlap. And then you can form a wide angle image, okay? So panorama is an option. And then one more thing. Maybe some of the sharp-eyed of you may have noticed at the beginning of the talk, when I took out this tripod, there's some white contraption on top of it. Now, this contraption is not something simple, okay? It's what we call a star tracker. Okay, originally I was gonna do a kind of like a more fun video where I actually show you all my equipment set up outside in the balcony, but because the neighbors are so noisy, I can't do that. So what I'm gonna do now is just take out the star tracker here. Okay, here it is. Actually minus this part. Okay, and this is a star tracker. Basically what it does is it follows the star, okay? So I attach my camera to, okay, the accessory is outside. So there's an attachment at the head here, and then there's a tripod head. So basically a tripod head that goes to the front of the star tracker. So kind of like this, okay? Stuff like this. And then I put my camera on at the top here, and then now what I do is I align. So this star tracker is a motor that rotates once every 24 hours, 360 degrees every 24 hours. So what happened is, if I align this axis right here, okay, so pointing from the back here and then sticking out the front, this axis, which is kind of like sort of pointing at you right now, if I align it with the rotational axis of the Earth, okay, excuse me, which means I point this to the North Star, more or less. It's not perfect, but I can just point it almost to a North Star, okay, or perfectly on the North Star. It's cool. Then I can track, follow the stars. Now, what happens when you follow the stars? You basically increase the exposure time limit for your photo. Okay, so you can take, like, instead of I'm stuck with 20 seconds with a 24mm lens. No, now I can do 3 minutes with my 24mm and take a full sky image of the Milky Way with a 24mm and expose for 3 minutes at a very low ISO. I'm sorry, I forgot to mention about ISO. So I have a low ISO, ISO 200 for 3 minutes. My image will be very clean, very low noise. So when you find that you set your aperture wide, and then you open your shutter based on the 500 rule. You also have to see what your ISO is. Usually ISO about 1600 to 3200 is okay, but the higher your ISO, the more noise you have, okay? So now if you can expose for a longer period of time, you can use a lower ISO to get the same brightness of an image. Okay, so like originally, if I take a 24 millimeter image of the sky, I do, let's say, without a tracker, 20 seconds. Excuse me. I have to do like maybe ISO 6400 or 3200. Okay, so quite high. But if I expose for 3 minutes at ISO 200, okay, well, there's a way to calculate what that equals to. Okay, so 6400 to 3200 is one stop, 3200, 1600 is one stop, and then to 800 is another stop. That's 3 stops. Okay, and then now 400 is 4 stops, 200 is 5 stops. So 5 times the light. If I convert from ISO into exposure time, so originally I was exposing 20 seconds, I multiply that by 5. So I do 100 seconds. It's less than 3 minutes, right? Just minute and a half plus 10 seconds. Okay, so for 100 seconds, I expose at ISO 200 and I get the same brightness, but now I'm at ISO 200. Okay, instead of that ISO 6400 image, which will be very, very noisy. So that's how the star tracker helps us get a better image. Okay, and I was going to do this demo of the world's fastest polar alignment, which would make Cress jealous to the core. I have this accessory and I have another floating platform that I can finish a polar alignment in less than 10 seconds. Okay, Cress, are you hearing this?
That's a star tracker. It doesn't work on me.
I know. Okay, anyways, yeah, that is kind of like the whole summary of basic astrophotography. I think that we have time for questions, or are we moving straight to Cress?
I think we'll straight move to Cress. Then at the end of the session, we'll do the Q&A session.
Okay, sure.
Okay. Before that, just for those who are curious, what's ISO? ISO is basically you can say the sensitivity of the sensor of your camera for the DSLR. So yeah, so this is why the higher the ISO, the more grainy it gets.
Actually, Qi-Zhong, sorry, pardon me. Let me explain that in more detail. I would say that it may look more sensitive, but actually what it is a gain. It's multiplying the signal rather than being more sensitive. Yeah. Okay, because sensitivity means that your sensor has an improvement. So it is actually gain, kind of like amplifying the signal. So you amplify too much, you amplify the noise too, and then that's exactly what Qi-Zhong is pointing out. Okay.
So yeah. So now we'll be moving on to the next speaker, Cress. So Cress is an active member of the Starfinder Astronomical Society, who also serve as Taylor's Astronomical Society's advisory organization. So they have organized numerous imaging and observation party, the IOPs, which I've been to. It was fun. And yeah, so Cress has also been an astrophotographer for how long? 5 years, I think.
Oh, 5 years now, yeah.
Yeah, so 5 years. So again, he has more extensive experience on astrophotography, and yeah. So now let's welcome Cress.
Hi, thanks, Qi-Zhong. Thanks for inviting me to be a speaker. I'm honored to be here. Hi, Derrick, and hello, everybody. Honestly, when Qi-Zhong invited me, I did not have any topics in mind to talk about. And in these 2 days, I was busy maintaining, doing servicing on my telescope and my mount. So I honestly did not prepare anything at all. And then while watching Derrick present these things with the presentation slides and everything he prepared, I was a bit ashamed because I totally did not prepare anything. So I took that 15 minutes of presentation to come up with a simple idea of astrophotography, and I hope you guys can forgive me because I am coming up with this is inside the shop. So I would like to start to share with you guys on the pictures that I have taken with my setup. So like just now when Qidong mentioned what is my favorite object in the night sky, I told him that it would definitely for galaxies it would definitely be M51, which is the Whirlpool galaxies. Right now I'm trying to show you the screen from my phone. Give me a while. Let me quickly scroll through that. Yeah. Okay. Sharing my screen. Okay. Can you guys see my screen now?
Wait for a moment. Yeah.
Can you see my mobile screen, right? Okay.
Yes.
So let me quickly scroll through my album. All right. This is the collection of pictures that I've taken over my past 5 years of astrophotography journey. So in terms of galaxy, this is the one that I like the most. It is called the Whirlpool Galaxy. Whirlpool Galaxy is M51 under the 51 object under the Messier's catalog. And it was also the first galaxy to be identified as a spiral galaxy. So if you guys can see the spiral structure, the beautiful structure of it. And back in those days, because those people, they don't have a very big and fancy telescope, they couldn't really resolve the details to this M51. So they thought it was just a faint nebula in the sky. So Charles Messier cataloged it as definitely not a comet, but it is something else. But back then he didn't know that it was a spiral galaxy. So, and until I think it was back in probably 1800s. Correct me if I'm wrong because I'm not that good with the history of it. With the advance of telescope, they zoom in enough to capture the details of the galaxy, and it is actually a spiral galaxy. And soon after that, with more advancement in telescope technology, they found out that it is not just one galaxy; it is actually a collision of two galaxies. If you can see, on the right you have a beautiful spiral galaxies, and on the left you have a disrupted galaxies, or what's left of the galaxy nucleus. And they are on a collision course, and this is what's happening. And if I can show you a few more, in terms of this sky object, a lot of us love to capture nebulas or nebulae. So these are what's left of the star when it dies. So our star, our sun is currently about 4.5 billion years old, and we estimate that it would have around 4.5 to 5 billion years of lifetime left. So when the sun dies, it will slowly shed its outer layer of hydrogen or helium or whatever to the outer space. And through the process of thousands or probably tens of thousands of years, the outer layer of the whatever star that is there, it will slowly become something like this, a nebula. So depends on the chemical structure of the sun's atmosphere and the sun's radiation and all those things. Different colors will be presented to your image. So like in this case, this is M20, the Trifid Nebula. So this is a very interesting object because first of all, it's beautiful. Second, you can see different colors. You can see a red color and a blue color counterpart. So this is a different types of nebulae. So on the right, the red color one is an emission nebula. So I'm sorry, this is getting a bit scientific, like what Derrick said. Astrophotography is half science and half art, and that's the beauty of it. So everybody who is doing astrophotography, you are both a scientist and you're at the same time you're also an artist. And depends on your preference, you can lean more towards the science part or you can lean more towards the art part. There's nothing wrong with it. But you have to learn a little bit of both. So like I said, on the right-hand side, the red color is emission nebula, and they are primarily in H alpha, which I will talk about later. It is a very thin emission of the hydrogen atom, where when it is excited by radiations coming from nearby stars. And on the left-hand side, you have the blue color nebula. It is a reflection nebula, reflection. So what it means is that it is actually some gas or dust in the space, and then it is reflecting off the light coming from the nearby stars. Hence, it's usually blue, but sometimes you find different colors. Okay, all right. So, and this is the annular solar eclipse that Qi Zhong and his friend went to last year, end of last year, the Boxing Day in the most southern part of the Peninsula Malaysia. Tanjung Piai is a very good place, but Starfinder, our astronomical society, we organize a trip to Tebedu, which is in Sarawak. Over there, you are right in the middle of the path of totality of the sun, of the eclipse. So you will get a very symmetrical ring of fire. If you're in Tanjung Piai, like the place that Qi Zhong was, you won't get a perfectly centered and symmetric ring. So that's for another topic for the solar eclipse. And again, galaxies. And this is probably the most famous nebula of all time, the M42, the Great Orion Nebula. And this is probably the only naked eye nebula that you can see in the night sky. It is absolutely a wonder. And if you have any chance to go out for stargazing, this is the first thing you have to see through a binocular or a telescope. It is amazing. And throughout the 5 years, you can see improvement to my images. Like this is back in the days where I don't have much technical knowledge and or money to buy better equipment. So the colors are a bit off and it's a bit noisy if you zoom in. The stars we have chromatic aberration, it's not round, things like that. So it is not a very difficult hobby, but if you spend time in it and probably invest a little bit money of it, you can get better and better and better, and you will definitely enjoy doing this hobby. And this is Star Trail. Okay, enough of sharing my pictures. So next thing, what I'm going to show you is because like just now what Chizong mentioned, in our Starfinder Astronomical Society, we do organize a monthly IOP, what we call as IOP, Imaging and Observation Party. So it is basically just a stargazing event where we go out to some dark side where you have to drive like probably around 2 hours because of the light pollution. Otherwise, if you live in some dark place or near to the jungle, you can see stars every day, but definitely not in the city, not in KL, because of the light pollution. That's why every month, and again, some of you might be asking, why do we have to be every month? Because we don't want any light pollution. And actually, the moon itself is a very, very big light pollution. So every month, we choose during the periods of new moon, which is if you're Chinese, 初一、初一, that usually is in our Chinese calendar, because Chinese calendar is basically a lunar calendar. So every first day of the lunar month, it is new moon. We will go to this dark side to do our stargazing event. So tomorrow will be our stargazing event. So I'll be driving to some dark side 2 hours away from KL, and I'll be doing the things that I love to do the most. And I'm happy to share it with you guys, because I have I'm still trying to do servicing on my telescope, and I have it fully assembled right here. So if you can see, this is my full setup for my astrophotography, and don't be intimidated, because it is not that expensive, and it is technical. You have to learn a lot of technical stuff. But I want to emphasize one thing, because in astrophotography, every different field of astrophotography has the advantage of its own. So do not discredit things like what other people do, like what Derrick do. He likes to travel on a tripod and a camera and a lens. That is what we call generalized as wide field astrophotography. Whereas if you're using a telescope with very, very high focal length and you're aiming into the depth of the universe and looking at very, very small object and very, very dim object, we call that deep sky object photography. And again, like what Derrick said, there are two types of astrophotography with telescope. So one of it is planetary, is a different category, and another one we call DSO, deep sky object astrophotography. Basically, is anything that is out of the solar system. So let me go around of my setup to give you a very basic introduction of astrophotography setup with a telescope. So you're gonna have three things, like what Derrick said. In his case, it's gonna be a lens, a camera, and also a tripod. So if you're using a telescope, it's gonna be 4 items that you must have. You're gonna have the telescope, of course. This is an 8-inch Ritchie creation telescope. You can see there's a mirror inside. So and also there are different types of telescope that I should probably share. Three types of telescopes. The one you guys are more familiar with is probably this one, this guy over here. I'm not sure if it's in the view. This guy over here. So this is a refractor telescope. It's very much like a lens because it has a lens in front and it focuses light by refracting the light and focusing it through the back of the telescope where you can put a camera or whatsoever. You can put an eyepiece so you can look through it with your naked eye. And this is a smaller refractor, which is a DIY telescope by our Starfinder Society. As you can see, it's basically just a PVC tube and some plastics, and we buy a very cheap lens from China. It costs probably the lens itself, I think about 20 to 50 ringgit. It's not expensive. Plus all the spare parts, this thing is cost just probably around 100 ringgit. This thing, the beginner refractor, you can get probably around 1,000. Anything lower than that, I wouldn't really recommend it. Probably 600 to 800 is acceptable. Anything lower than that price, do not get it. Like those telescopes that you can get from Toys R Us or any other toy stores, those are for kids. Please don't get those telescopes like 200 or probably like 300. Don't get those. Yes, you can magnify things, and it falsely advertised by saying you can go maximum magnification up to like 400 or 600 times. Yeah, it is true, but at that magnification, it is not usable at all because of the size of your telescope and also the quality of your lens. So do not buy anything of those. If you want to invest in astrophotography, like Derrick said, in his case, tripod is very important, but in deep sky, DSO astrophotography, telescope is very important. You don't have to buy a very expensive one, a beginner one you do, but that would cost you probably around 1,000 ringgit. All right, and yeah, refractor. And then we have a second type of the telescope. It is called reflector, means reflect like a mirror. It reflects light. So this is actually a type of reflector. It has mirrors at the back of it, where the light goes in, reflect the back of the mirror, which we call as primary mirror. And then it focuses the light at the end of this thing. It's actually another smaller mirror, which we call as secondary mirror. And at the end of it, it focuses all the light all the way to the camera over here. So this is a reflector. And the third type of telescope, it is called cathode dioptrics. So it is a combination of lens and also mirrors. So I do not have it because I'm not rich to buy so many types of telescope. But it is basically, for example, the Schmidt-Cassegrain telescope, SCT. It has a very thin kind of glass, a correction plate, we call it. It's actually some kind of a lens, a glass that corrects the distortion of your light path. So if they have some kind of lens and mirror at the back, so same thing, light comes through from in front, passes through the lens, go to the mirror, bounce to the mirror at the secondary mirror here, and then goes to the back of it. So that is usually much more compact, and it is light, it's compact, it gives you a very high focal length. So 3 types of telescope. Enough of telescope. Let's move on to the second thing of your basic astrophotography startup. You're gonna have same with what Derrick said. You have a very sturdy tripod. If the tripod is very cheap one, do not trust it because all these things are very heavy and very expensive. You do not want to rest all of this weight on top of your flimsy tripod. If it falls, it goes your several thousands of dollars. And the third thing that you must have, of course, is your camera. I'm not sure how can I adjust it. I guess you guys have to live with my grainy voice. All right. So the third thing is about camera. So camera we have if you are serious at photography, we have mainly 2 types of camera. Of course, the first being a DSLR. You can just grab your DSLR. You just grab a DSLR or mirrorless because now it's a very trendy thing. You can buy an adapter and you can attach at the back of the telescope. No problem. But if you are more serious into astrophotography, we use some kind of a dedicated astronomy camera called it can be a CCD or it can be a CMOS. But what's special about it? This is the camera, by the way. This is the camera. So if you see there's a big fan at the back of it. So the special thing about this dedicated astronomy camera, as you can see, there's no button, there's no LCD screen, there's nothing. There's only a power source and some USB cable going into it. So when you are into this kind of dedicated astronomy camera, the only way you can do astrophotography is by controlling it using a laptop. So everything, all the wirings, it goes through a series of crazy loops and then all the way to your laptop. And you control your camera with some kind of software, which I'll talk about it later. So some people might ask, why do we ditch your DSLR, which is such a convenient invention, and go for this crazy camera with no screen, no button, and and it's even more expensive than DSLR, most of them. The reason is because this kind of dedicated astronomy camera, back in the days, it usually is CCD, but with the advancement of technology now, the CMOS technology is catching up, and CMOS cameras are equally good. So those CCD and CMOS sensors, they are extremely sensitive, unlike the sensors on your DSLR, because sensors on your DSLR, they are designed for everyday daytime usage. So they have a lot of unnecessary things. I wouldn't say unnecessary, but things like IR filter and also Bayer matrix, Bayer filter, it blocks away a lot of the light and reduces the efficiency of your sensor. What this dedicated astronomy camera does is that they are usually monochrome, means black and white, no color. And you might think that it is crazy, but I'll explain to you why we use monochrome camera. Monochrome camera, first, it is roughly 4 times more sensitive than your color camera because of the Bayer matrix. Well, I will give a short introduction because basically what your DSLR camera sensor does is, it is essentially a black and white sensor. Currently, I don't think any sensor can detect light. They are all monochrome sensors because there's just the digital values of the brightness of the lights, the photon that is hitting the sensor. It is just digital value. So there is no color values to it. It's all in numbers and it's all black and white. And how do we come up with color cameras then, you might ask? It is all thanks to an invention called the Bayer matrix, a Bayer filter. So a Bayer filter is just like a filter. It's just like a filter, something like this, a piece of glass in front of the sensor. And for every 4 pixels, they will arrange in different filters that only allows light like green color RGB, red, green, blue color that pass through. So only red color pass through certain pixels, hitting certain pixels, only green and only blue hitting certain pixels. So that your sensors only registering the brightness of red, green, or blue. So with this information, then by using some algorithm to combine the values of RGB into a single pixel, there you get your RGB color sensor. So back to my monochrome sensor, what it does is it's actually removing your Bayer matrix and also your IR filter, because in the next sky, a lot of those emission nebula, they are in the range of far infrared that are in hydrogen alpha, which is in the range that our human eyes are not evolved sensitive to see all those lights, but sensors, they are very sensitive to it. The thing is, our daytime, normal day, everyday use DSLR, they block away all those lights because it doesn't seem natural to human eye. So in astronomy cameras, we remove all these extra things to reveal a full spectrum of the lights that we can see. So full spectrums means from infrared, the far infrared that our eyes cannot see, and also to the UV light. Of course, there are some other special cameras that can even detect gamma rays and X-ray, but I'm not going to talk about that. Those are some very serious astronomy. In amateur astronomy, this is the camera that we use. All right. Now the fourth thing. The fourth thing is very important in astrophotography, and Derrick gave a very good brief introduction to it. It is in Derrick's case because he is using a camera and a lens, and the lens are typically in the range of wide field, 10 millimeters, and to very long focal length lenses, probably 200 or 400. But in the case of telescope, which is, for example, in my case, this is 1,006 millimeters. So it is like 8 to 16 times or probably 32 times more than your conventional lenses. So it really zooms into the very, very small, very, very tiny things in the sky. So in such magnification, because the way the Earth rotates, so the sun, the moon, the stars, they all rise in the east and set in the west. In such magnification, that even the stars seems to be moving so quickly that you could probably take like the 1 second to 3 second images if you don't have a star tracker. So just now Derrick showed you his tiny star tracker. Those are very good for DSLR and the lens because it is portable, it's light, you can take it, you can go anywhere, put it up, plug, and you can start shooting. But in the case of DSO astrophotography, you will need something like this. So this is the body of the what we call as equatorial mount. We simplify as EQ mount. This is the body of it. Basically, what it does is that let me show you a cool thing. So this is the hand controller of your equatorial mount. Wait. This is probably the sexiest sound that you can ever hear if you're into astrophotography. So what it does is it has 2 motors inside this telescope mount. It tracks the movement of. It tracks the. Is my video freezing? 其中. Okay, let me refresh my video. Sorry, guys. I think my phone is getting heated up, so the video stops working. Okay. All right. Sorry, guys. So just now, what I'm trying to show you is the way that the telescope can move. The telescope mount moves. Everything controlled by this hand controller, or I can control it using my laptop, which I'll show you later. So because the way the Earth rotates, everything rises from the east and sets in the west. So you have to set up you have to have this machine, which we call as an equatorial mount, to help you track the movement of the stars, so that you can take a much longer exposure, like probably 3 minutes to 5 minutes, and some can even go to 10 minutes or 20 minutes per picture, so that your star, it stays like a pinpoint star, like it should be, not moving, trailing, shaking, or any nonsense like that. And this is the heart and soul of basic astrophotography. Again, like telescope, do not get a cheap one, because cheap one, you couldn't do anything. It doesn't track well, and then your stars will go crazy. It won't be a pinpoint stars. So here you go. 1, 2, 3, 4. The 4 very basic thing before you can start astrophotography. And like I said, it doesn't have to be expensive. It can be a very cheap telescope. It could be your existing DSLR. It could be a very cheap equatorial mount, would cost you probably around the cheapest one. The cheapest reliable one would be around 1K each, 1K each. And then usually it comes with their own tripod, because the tripod usually is designed to mate with your equatorial mount. And there you have it. That's the very basic photography stuff that you can have. And it's not expensive. It's very fun, very easy to learn. As you go more advanced and you buy more stuff, you actually have to be frustrated all the time, trying to be very technical and trying to solve all the problems that come with it. So, for example, if you go deeper into astrophotography, you gotta have this. This is actually a small lens and a very small camera behind. This thing, we call it auto-guiding system. It could be a lens, it could be a small telescope, it doesn't matter. As long as it's something that focuses the light with a decent focal length and it's a small camera. What it does is that, because no machine is perfect, if you only have an equatorial mount, even if you buy some crazy expensive branded telescope mount, could cost you probably more than 100K. Those things, they are not perfect. They are near perfect, but they are not perfect. So probably you can put on a heavy telescope and you can do your photography probably around 2 minutes, 3 minutes, or maybe even 5 minutes. And then it start to trip. It's no, because the machine cannot fully imitate and counterbalance the Earth's rotation. So, which is why we have a very cheap way, a poor man's way of tracking the precision of your tracking, of your telescope mount tracking. I think my phone started to freeze. I'm sorry. I have to reshare the thing. Right. I hope my camera is back. So what the auto-guiding system is another smaller set of telescope, a smaller telescope and a camera, and it takes the picture of the sky, which is where your main telescope is aiming. This is your auto-guiding. It is aiming roughly at the same area of the sky, and it is taking a very short exposure of the sky to have a look on the stars. So for example, every 1 second or every 2 seconds, it will take an image. It will see certain stars. Usually we select some brighter stars as our auto-guiding stars. So what it does is that it will detect the movement of these stars. It will put on a crosshair, so that that's where the star is, a crosshair. That's where the star should be, right in the center. But because of the imperfection of your telescope mount, suddenly, sometimes it will drift away here, sometimes it will drift away here, sometimes it will drift away here, this much, a little bit here, that much over here. So the auto-guiding system, it detects the drift of your guiding stars, and it will issue some counter movement to bring back the stars. Let's say the stars drift here, it will bring back here. The stars drift to here, it will try to bring to the center, always. And it do this in the interval of probably 0.5, 1 or 2 seconds. It's up to you. So in that way, it is if you are an engineering student, it is actually a closed feedback loop. So it takes an image of the stars, it analyzes how far away the star is drifting away, and it issues a feedback command to bring back the stars to the center point. It is an active closed feedback loop. It is cheap, it is doable, everybody can do it, and that greatly improves our tracking of the deep sky object that we are trying to shoot. All right, so I guess that's enough about auto guiding system. And then the next thing is, I promise you to explain it to you why we are using monochrome sensors. If you notice in front of this camera, there's a smaller piece of this thing. And you might be wondering, what the hell is this? It is actually called a filter wheel. So inside this filter wheel, there are 5 filters inside. It depends on what kind of things that you want to shoot, because your camera is monochrome. If you want to shoot colors, you gotta have at least R, G, B, 3 filters, RGB, to make up your color images. And if you are imaging in the middle of a city where there's a lot of light pollution, it helps if you use narrowband filters, which comes in H alpha, S2 sulfur, and also oxygen O3. So these narrowband filters, it only allows a very, very narrow spectrum of light to pass through, specifically a certain wavelength. For example, H alpha, I think, is 656 nanometers or 646. Correct me if I'm wrong. I think it's 656 nanometers of light to go in, and then sulfur, another different wavelength to come in, oxygen, different wavelength to come in. So in professional astronomy, astronomers, they use this narrowband techniques to highlight the chemical composition of the nebulas, of the explosion of supernovas and all those things. Because in the universe, they are because of the process of the what do you call it, solar activity, the way that the sun creates all those elements. Forget me, I couldn't think of the technical term right now. So the sun is technically a big fireball that undergoes constant nuclear fusion that fills hydrogen into helium, helium into lithium, and slowly into heavier and heavier elements until ions. So when the sun explodes, when it dies, it spit out all these chemical elements. And the scientists are particularly interested in, like I said, hydrogen, HA, hydrogen alpha line, because the universe is abundant in hydrogen, has like 98 or 99% made out of hydrogen, and then sulfur and oxygen. But of course, if you go into serious professional astronomers, they have other filters that can bring you the details of different chemical elements. So I could probably, let me see, I could probably show you how the filter looks like. Just give me a minute. So I am now unscrewing my camera. So if you can see, I'm sorry, let me do something very quick. If you can see right in this hole, that is a camera sensor, and in between there is a filter. And if I could rotate it by hand, sorry, it's too difficult, so I'm not going to do it. So basically, it's a carousel. It is a carousel of different filters. So because everything is connected using USB cable, I can actually control the camera and the filter wheels from my laptop. So, okay, to the software part, there are a lot of softwares that we can use to control all the things that you see up here. I'm using a software called Astrophotography tool, APT, but it is free and it is very advanced. And there are some others software like SGB Pro, MaximDL, tons of software that you can use. But I'm going to show you this one. So, for example, camera disconnected. I am now reconnecting my camera. Camera connected. And yes, another reason why we use dedicated astronomy camera, other than it is monochrome, it is also coolable. So if you can see, I am cooling my sensor right down to, I want to cool it down to -10 degrees. Right now it is at -8 degrees. So just now Derrick mentioned something about the sensors and about the noise that it generates. So mainly if you are doing astrophotography where it is an extremely low light photography and you have to do long exposures, majority of the noise, like all these things, all this are noise, in your image comes from the heat of the sensor when you are doing long exposure photography. And it helps a lot, like a lot. I have to emphasize that a lot. If you can cool down your sensor to sub-zero temperatures. Like for example, the Hubble Space Telescope being in space and all the other great observatories being in space, they are cooled down to could be like -200 or -100 to -200 degrees Celsius. So in that temperature, your sensor can capture the lights, the photons, very, very efficiently without generating too much of the noise. So same thing we are trying to replicate here, except that we couldn't really cool it down to -100 or -200 degrees. If you in Malaysia, where our temperature is like around 30 degrees, you can cool it down to probably -10 to -15. If you're in places like Canada, where they are during the winter, where the temperature is probably at -20 degrees, you can cool your sensors down to probably -40, -50 degrees. That again, that really helps with your image capturing. And next thing I'm trying to show you is the filter wheel. So let me reconnect my filter wheel. Filter wheel connected. And then these are the list of filters that I have. I have R, red, green, blue, hydrogen alpha, and L is for luminance. It's basically your normal day image without filtering any kind of the lights. It is RGB, but we call it luminance for some reasons because in the image processing part, luminance actually means something. It's like the data that you are actually trying to capture. I will talk about all these different filters in a minute. So, like I said, I can control my telescope, everything from the computer. So when I connected my filter wheel, I guess my camera hangs again. Sorry. So when I'm connected to my laptop, I can, let's say for example, right now I finished collecting data for my red color. Now I want to go to my blue color. I just give it a click, moving. Then you can see inside the filter wheel, it is rotating. So you don't have to like manually change the filter or whatsoever. Everything is done with the computer. And for the camera, you can control the temperature of the sensor with a click, or you can take a picture. Or you can take a picture with a click. You can press live view, or you can press shoot. I have nothing to show here because I can't seem to find anything to shoot right off the window. But if you are out there in the night sky, you're shooting the night sky, when you press live view, depends on how long you want to expose. It could be 1 second, it could be 10 seconds, it could be 3 minutes. Then you can start to see the wonders of the night sky. All right. Enough about that. How much time do I have, Qizhong?
About 15 minutes, I guess.
30 minutes.
15.
15,
let me see. Oh, sorry. 5 to 10 minutes. Sorry, 5 to 10 minutes.
5 to 10. All right. Then I guess I'll have a quick introduction to before I show you on the image processing part. These are the list of the software that you can use. I hope somebody is recording this. So this is the guiding software. And this Stellarium, it is very, very popular among the amateur astronomers and also the hobbyists because it is free. For desktop, it is free. For mobile version, I believe you have to pay like 10 to 20 ringgits. It's not expensive. So if you are starting out into astronomy in general, not astrophotography, just astronomy in general, probably you can start with just go out to the night sky, just look up, lie down, gaze up to the night sky, and learn about the constellations, about the brighter stars, about the some of the interesting things in the sky because there are some of the asterism, like for example the Big Dipper, the north, which also we call as north pointers, the 北斗七星. It is actually part of Ursa Major, the Big Bear. But the Big Dipper itself, it is not a constellation, it is an asterism. Asterism is just a pattern of the stars that we recognize, but it is not a constellation. So for the southern hemisphere, you would have the Crux or the Southern Cross, which always point to the south. The Big Dipper always point to the north. Those are naked eye object where you can see it's very big. So for others, you can just go out to the dark side, just appreciate the night sky, the stars, the constellations, and all those things. And you can easily do that using a mobile app like the Stellarium. It is paid, but you can download something probably like the Google Sky Map, which is free. Skywalk, and I think Starwalk or Star Map. Those are free software, and they give you roughly the same thing. So if you can see, this is Stellarium. And the reason why it looks orange and red is because our eyes are, when you're out in the dark side, your eyes get adapted to the dark, and you can when your pupil opens up, you actually lets in more light, just like your lenses. When you open up the aperture, you open up, letting in more light. Same goes with our eyes. But the thing is, our eyes are very sensitive to light. So if you are exposed to blue light or white light, there goes your dark adaptation, and it could take probably up to 30 minutes before you get dark adapted again. So when we are out, we try to use flashlight in the red color, everything in red color, because red color is the most visible light, and it doesn't have enough energy to excite the cells to break your dark adaptation. So we try. My screen is in orange. You can turn it off. So this is the and it is actually simulating the next guy in your location at your time. So for example, just now we talked a lot about Ursa Major. This is Ursa Major. So it is also known as a Big Bear. And if I could turn on the constellation part, there goes the bear, but it is setting, so you can only see the tail and the backside of it. But if I could turn back time, I'm a time traveler, I can turn back time. There's a cool thing about all this planetarium software. You can select any date, any time you like, and any location you like, and it will simulate the night sky for you. So this is the Big Bear. This is the Big Bear. So Ursa Major, and then over here, this star, 2, 3, 4, 5, 6, 7. These 7 stars together, they form the asterism of Big Dipper, or the North Pointer, or in Chinese, the 北斗七星. And just now we talked about the comet Neowise. Comet Neowise at this today, and for the next few days, It is probably around this region, near the Ursa Major. So as you can imagine, when the sun sets, like probably 8.
Cress,
Yep.
your video is a little black.
Oh, all right. Again, my phone is throwing tantrums again. I'm sorry. Can see now, right?
Yeah.
Okay. So, for example, tomorrow when the sun sets at 8 o'clock, the comet will be somewhere around here. So, as you can see, it is quite low for Malaysia. It is probably around, if I'm not mistaken, it's around 4.4 to 5 degrees altitude. It is very low. But like Derrick said, if you can go to a place with a clear horizon, you can climb up some kind of building or tower, just look towards west, northwest, around this direction. The comet near-wise will be somewhere around there. Okay, let's track to the comet near-wise. Let's go back to Stellarium. So it is a very useful free software that can start to learn about all the constellations, and all the stars, and everything in the sky. And it is summer, so it is a best time for people and wide field astrophotographers to go and take a picture of the Milky Way. So the Milky Way actually it's a stretch of a band of light, cloudy band of light that stretch somewhere from the southwest all the way to the northeast. So that is the center galactic core of our Milky Way. But this whole stretch of things, we call it the summer Milky Way. But of course, there are other seasons like the winter Milky Way, the autumn Milky Way, and the spring Milky Way. Okay. So again, Stellarium, a great software. It's free. Go and download and play it yourself. You can learn quite a few things just on your own. And if you have someone to teach you a thing or two in this software, you can learn a great deal. But of course, the best way to learn just to go up to a dark sky, find somebody, join a local astronomy, astronomy is a great place. Jijong is a direct, it can teach you a lot. Okay, so to close things up, I'll give you a quick look on the image processing software. So there are great different image processing software depends on which one you want to use. Some of them are free, but the good ones are paid software. The good ones are paid software. And what it does is because, like I said just now, we are taking the image of the night sky, and because of the long focal length, and so the way that this the stars, the heaven moves around us, we could a limited amount of exposures per image. So, for example, I'm doing like 2 minutes of exposure pictures, and I'm taking probably like 20 to 50, 60 pictures of frames. So when you collect all those data, you go back home, go to your computer, open up your image processing software, and you can start to do something called stacking. Stacking is essential to this kind of photography. So without stacking, none of your images will look nice. It will be very, very noisy. The noise from the heat of the sensor, the noise from the random noise, and all those things. So what stacking do is it actually literally stacking is like taking a lot of pictures, picture 1, picture 2, picture 3, 4, up until 50, 60, or 100. And then it stacks all of them together. Because the noise are mostly random. When you stack all the image together, the image processing software will analyze and identify which pixel are noise and which pixel are the actual valuable data. So in astrophotography, we have this term called SNR, which is the signal over noise ratio. It's basically signal S over N noise. So what you want to do in astrophotography is to increase your SNR, signal to noise ratio, because in low light, extremely low light photography, you are dealing with a huge amount of noise. And if you can get rid of all those noise, your image will be crystal clear, very sharp. And what stacking does is, like I said, it stack all these images, and then it analyzes all the random noises. It digitally eliminates all the noise and valuable data, and then thus removing your signal noise ratio. So I'll give you a very quick look on my image processing software. So blah blah blah. For example, let's say I want to do M20. Okay, so your image processing software, you have to load a lot. You have to load your light, which is your data, and you have flat, you have dark, you have bias, you have a lot of things. These are all what we call as calibration frames. And I guess I do not have enough time to talk about all those things. It is basically calibration frames. You have to do separate images so that you can stack on top of your light data to calibrate your data to give a better precision, like to eliminate your camera noise, to eliminate your flat field illumination, and all those things. After you select the light data, you have to go through a series of very technical things to tell the software how you want to analyze your images, your stars, how they want to get rid of noise and all those things. And then you are stacked with a lot of different stacks of different filters. Like for example, if I want to do, sorry, I should probably go. So for example, my M20, I have, sorry, probably. Okay, let's use M20. So I have the H alpha over here. Oops. So I just load all those images of H alpha, and the software will ask me, what are these data? Is it a luminance? Is it a red? Is it green? Is it blue? Or is it hydrogen alpha, hydrogen beta, and all these narrowband filters? So you just tell the software, what is this data? Is it taken in red? Is it taken in green? Is it taken in blue? Or in some other narrowband filters? And then you click OK. For example, this is H alpha. I click OK. And then you continue to load all your different images taken in different filters. So in my case, I'm taking RGB, red, green, blue. So what you do is you load, say, 40 images of red images, 50 of green, and maybe another 40 of blues. You load into the software, and the software will stack 40 red, 50 green, and 40 blues. And then if again you use the software to stack RGB together to form a nice colorful image, what I've shown you in the beginning of my presentation. So that's how you get the color images. And for your information, the Hubble telescope, the first Hubble telescope, it is using the same technique. It is basically a set of mirrors in space with some cameras and some filters. The cameras are monochrome. It is a cool sensor, monochrome, like what we are using here. And then they have different series of filters to highlight different chemical elements of the things in the night sky. And then after that, the data will be beamed down to the Earth, where the astronomers are using the Hubble data to do exactly the same image processing that we are doing. So what we are doing here is, yeah, you can call it amateur astronomers. We are just like those guys operating the Hubble Space Telescope, then processing the data, and then doing all those beautiful images for your pleasures. We are doing the same thing. The only difference is our telescope is smaller, our things are, and we are below the Earth's atmosphere. We are blurred by the atmosphere. And other than that, we are actually doing crazy science like the Hubble guy does. So I guess probably I ran out of time, Jijong.
Yeah. So so now we'll be moving on to a mini Q&A session.
Right. Sorry for taking so long of time.
It's all right. It's all right. So for anyone who wants to put down a question, please do so on the chat. Just before we answer them, so Cress has mentioned something called Ritchie-Chrétien telescope, the RC telescope. It's basically what Hubble Space Telescope looks like. So it's a pretty cool telescope. I would really suggest you guys to like see how it works because it's pretty cool. So yeah. So with that, does anyone have a question? Okay, let me see. Okay, so while we're waiting for people to send in questions, could maybe Cress and Derrick like just say what got you guys into astrophotography? Maybe let's start with Derrick.
Hi. Yes. Okay. Sure. I actually never bothered with astrophotography before this. I'm a visual observer. But I think that everyone is taking photos of the night sky, and in 2013, a friend lent me his camera, and I started. Yeah. So I mean, I still prefer visual observations. For example, a lot of deep sky objects are visible through binoculars and stuff like that. But for instance, the comet recently, Comet Neowise, I was searching for it here in Thailand, and I couldn't see anything with the naked eye. But I was shooting with my camera anyways at the guesstimated spot using a star map. And I found it because I took an image. So, you know, that's kind of what's the rewarding part of astrophotography for me.
Oh, nice. So how about Cress?
Well, as for me, I guess it's almost like everybody else does. When I was small, I look at the TV and some probably National Geographic or any kind of documentary talking about the space stuff. And when they start to show Hubble Space Telescope images, I was totally mind blown. Boom! And from that point onwards, I've been having interest in astronomy for a very, very long time. But the thing is, in Malaysia, I guess probably a lot of you are having the same problem as well. You don't know where to start. You probably don't even think that the Milky Way is visible in Malaysia. It is. It is visible and it's super beautiful. The thing is, we are living in a city with a very heavy light pollution. You probably don't even see more than 3 or 5 stars if you look up. So that's the thing. And as I grew up, I started to, with Google there, I started to Google up, and that's where I found the Starfinder, the local astronomy club, and I started to join these guys. And that moment, I was totally hooked. I was totally what we call poison. So I started to invest some money into it, and I started buying my first telescope probably around 2015. But back then, I don't even know how to use it. like how to focus, how to look at it, nothing. And then I joined the local astronomical, starting to meet these guys. They teach me a lot of things. And then in 2016, March 9, March 9 or March 19, there was a total solar eclipse in Indonesia. So I joined these guys for a trip to Indonesia, and yeah, that's the moment. The sun, the moon, the earth align in a perfectly straight line, and you are standing right under the shadow of the moon, casting on the earth, and the sun turns into a black hole sun. It is literally black with some flimsy, wispy, eerie thing around the sun, the corona surface, where you can only see during a total solar eclipse. It is absolutely magnificent. And I would say this to everybody: you cannot die if you don't watch a total solar eclipse. If you don't never watch a total solar eclipse, don't die. Go and watch one and start planning. Okay, so that's probably where I first started to get serious in astronomy. Thanks.
Cool. So now the first question is there is any one type of telescope better than the other? So
the answer is no. Each of the telescope has its own advantages and disadvantages, because the telescopes, unlike camera lenses, they are fixed at only one focal length, and you can only like what Derrick said just now, focal length together with your camera sensors determine the field of view that you can see. But being in the telescope hobby, your telescope is fixed, your focal length is fixed. The only thing you can change is your camera sensor size. That's what Hubble is doing anyway. Hubble has, I think, 3 to 5 different camera instruments on board. So by changing different cameras, instruments, different sensor size, you can actually get the effects of zooming in and zooming out. Well, we can't do that, obviously. But for amateur astronomy, we can get accessories like reducers or ballows to zoom in or zoom out. But it involves you taking out of your telescope and putting in or taking out some other things, which is not convenient. So, which is why each telescope has its pros and cons. The longer focal length ones are generally good for small objects like galaxies, planets, and planetary nebulae, and some of the smaller things. I could give you these 3 examples. And as if you use a wider field of telescopes, say 400 millimeters to 600 millimeters of focal length, or probably even 200 millimeters of focal length, you can capture things at a larger structure like the NGC 7000, the North America Nebula, which is huge, or the Veil Nebula. It is, I think, probably as big as 8 full moons. Sorry, I couldn't remember, but it's huge. So different telescopes are built to capture different things. So there's no one thing king of telescope. There's no such thing.
Let me add something too to what Cress said. For Newtonian telescopes, since it's a mirror, it can be made larger for a cheaper price. So they tend to cost less, but because they are larger, you need a larger mount to mount them. And then the other problem is, if you are taking an ordinary Newtonian configuration, your camera is sitting at the side of the telescope tube. So you have a balancing issue with this Newtonian configuration. So that's one thing to consider as well. And that's why a lot of images use refractors or compound, Ritchie-Chrétien, Schmidt-Cassegrain, Maksutov, etc. to image, because it's more balanced. I think that one more thing is there's a lack of interest today for visual observing. Okay, I think that I would encourage people to do visual observing too in lieu of astrophotography because, I think astrophotography is good. The reason why I didn't take Cress's route is because what Qizhong mentioned earlier, So that situation where you took all the time, setting up and then it's cloudy, it happens so little to me. Why? I look up, oh, it's clear. I take my tripod, I take my little star tracker, blick, 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 5 minutes. Polar alignment takes 10 seconds and I'm done. Okay, and it's not accurate. I cannot go as far, as deep as what Cress does. He can take planetary, the Ring Nebula, or whatever, M57 or Eskimo, whatever. But I can take star fields. Okay, I sent my presentation to Qizhong, and I hope he can share it. Okay, and then you can see the images, the potentials. I can do. I've done the longest focal length I've done with a star tracker is actually 400 millimeters. So that's very close to telescope territory. Of course, I'm still limited. Okay, my exposure is, I think the best I've ever did so far is 90 seconds. Very crude. Okay, there are people that can do minutes with the star tracker. So it's a matter of choice, money, budget, time, everything. Okay, that's it.
Just a little bit to add on to what Derrick said, the polar alignment part, because I realized I missed out that huge important part in my presentation just now. So like what Derrick said, his walkthrough astrophotography is portable and convenient. Polar alignment only takes like 10 seconds. But in astrophotography, like what I'm doing now, the deep sky, in the clear sky, you would take probably do my follow and the second night again I have to check my fingers for the so it is very very.
Hello?
I think his connection was bad. Well, I think what Cress trying to say is if you're experienced, polar alignment takes probably 10 minutes, 5 minutes. But I don't know. I think is his internet connection out or something?
I think so. Yeah.
Looks like it broke up.
Hi,
Yeah.
Cress.
Yes, but yeah. I mean, I think I understand what he's saying. It can take 10 minutes if you're done. But again, there's a setup time. You have to connect all the wires. You have to connect all the computers and stuff like that. So for me, I hate doing those things. I'm just too lazy.
Cress, are you still in a call?
Yeah, I'm still here. I guess I just got disconnected for a while.
Okay. One more question before we move on to Mr. Doran's part, which is if you have a fixed budget, like let's say for deep sky photography, which component should we invest on first?
Derrick, you want to start?
Sure, I'd invest on the equatorial mount because the equatorial mount is your feet. You need to have the most steady feet before you can get a good image, right? So if you have a good equatorial mount, you can get a smaller scope first, lower budget, but it works. And then you can upgrade to a better one later. You already know how the mount works, everything, so all you do is changing the optical tube assembly and that's go. But I guess I'll let Cress give a more experienced answer because, it is my experience based on observing for almost 30 years now. But I guess astrophotographers may have different considerations, huh?
Well, when I first started my astrophotography journey, those guys are telling me that you should get a good solid mount if you want to invest your money. and I didn't listen to them. I was thinking, of course you have to buy a good telescope. You have to buy a big one. The small one can carry it, no problem. And I learned it the hard way. I mean, look at my setup right now. It's a big telescope on a very, very small mount, and it is exceeding the limits, and I am struggling because of that. So this is learning from experience, because I didn't listen to people like Derrick back then. I focused on the telescope, not on the mount. So I learned it the hard way. So my advice for you guys, hire a really, really good mount, a solid one, so that it doesn't give you problem and you can just enjoy doing whatever things that you like to do under a limited clear sky.
Yeah, that's true. I like to see like the lens of a DSLR as a telescope itself. I mean, it basically is. So with that, you can start off with a DSLR, then with a smaller telescope, then eventually to a larger Cassegrain or RC, whatever. So yeah. Mr. Dorian has asked, what is the most massive or distant object you have photographed or observed? So I repeat, Mr. Dorian asks, what is the most massive or distant object you have photographed or observed? Let's start with Cress.
The massive one, I think it's definitely going to be the Milky Way. Nothing can beat that. It takes the whole sky. The most distant one, I couldn't really tell because my main passion is into photographing the galaxies, and those galaxies are like 50 to 100 to probably hundreds of millions of light years away. And I did not keep track of how far away are all those galaxies, but it's definitely galaxies. I don't know which one.
Okay, my turn, right? Is it my turn now? Okay. So one day, I was in Arizona. I walked up to a guy with a big telescope. I forget, I think a 12.5-inch or 16, I don't know. I can't remember. But he told me, hey, come over here, have a look at this. He points to me, points to this star-like object in the eyepiece. He says that look right at the center. Right at the center, you see that little star? That's 3C273, a quasar. So that's the most distant object I ever imaged with my eyes, okay? It's visible to the naked eye. Actually, it's not that dim. And was it magnitude 13 or something? I can't remember. For imaging, yeah, I cannot run away from what Cress said. I think the Milky Way, maybe. Well, actually, Cress, is the Whirlpool galaxy more massive than the Milky Way? I don't.
If I'm mistaken, it is.
That
and,
image.
Well, Andromeda is easily larger than Milky Way.
Yeah. Andromeda is easily larger.
That is a debate. It is still a debate. Back in the days, they said Andromeda is bigger, and then they said it's probably equal. Now there are some research saying that maybe it's smaller. So we don't know.
Yeah, they can make. Yeah, that's true. Yeah, we're not sure. The same, I guess. Yeah.
Now the next question is, are, for example, photographs of Earth from the ISS considered astrophotography?
Well, I would say that as long as you are shooting towards the heavens, it is considered a form of astrophotography. That's at least that's what it means to me. Over to you, Derrick.
Well, I think it is because first of all, you're in space itself. So the only way you can look at the Earth that way, from that vantage point, is from space. So basically, you're using astronomy for your photography. So it must be, I mean, for me, it must be considered astrophotography. So.
Okay, so I've just searched. 3C273 has an apparent magnitude of 12.9.
13 magnitude. Okay, good.
Good memory, Derrick. Good memory.
And the last few questions, one of it is for aspiring astrophotographers, what is the one piece of advice you would give to them? Let's start with the wide view first for from Derrick.
Okay. Wow. I won't even limit this advice to wide field or narrow field or anything. I would say that if you want to do anything astronomy related, learn the night sky. Because if you're familiar with the night sky, you know, it's more than once, okay? Many times this happened. Like, say, oh, just take Eta Carina. And my friend is like looking at me like, what the hell are you talking about? You know, and pardon my language. But it's like, oh, it's there, it's right there, right? Say, oh, what do you mean? Oh, yeah. Maybe he hasn't seen it before. In my mind, I thought all the friends that come out are knowing the night sky. So I have to tell them, oh, okay, basically this object is, you know, Stellarium or what's the other app I forget? Sky Safari, yeah. And then here it is, okay? But if you know the night sky, you can step out right now at a completely unknown place. And then say, okay, that's north, that's south. I know the Milky Way is going to rise over here and set over there at about what time. The moon's going to rise what time. Jupiter is, okay, right east of the Milky Way, Jupiter and Saturn, blah, 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 blah. You know everything in your head just like that. And I think that would be the best advice I say to start off.
Yeah, that's I've heard from some people. It's actually Wei Hao. So if you know the night sky, you won't be lost anywhere. So yeah, basically with the knowledge of the night sky, you can know exactly what object would rise, what object would set, where is it, and sometimes even more important, where are you if you are lost in an unknown island. So yeah. So how about Cress?
Yeah, I couldn't agree more to what Derrick said. That is probably the first and most fundamental things that you should do. And it doesn't cost you a penny. It's free. Just go to a dark side and you can start practicing it. But the thing is, because with the advancement of technologies, you can know all these things through just by pointing a phone with all those astronomy apps. It kind of taking the interest away from people, because when you're new to this, you might be asking yourself, why should I learn all these things? When I have this app on my phone, I can point to it and I can know, oh, that is Jupiter. Oh, that is Mars. And that is Eta Carina and all those things. And I would say that go and learn. It definitely benefits you one way or the other. But from my experience, it is not easy because I haven't met a lot of people who can do what Derrick said. Like the whole planetarium database is right in your head. I only met a couple of people who can do that. It is not easy, and I'm still trying to do that. So, and it's definitely going to take you a long time. So, in the meanwhile, if you want to invest into something, I would advise you to start small in a baby step, and don't like yeah, you can dream as big as you want, but start small. Take your baby step. The first thing if you want to buy something, first thing you're gonna get is probably a binocular. And if you want to start astrophotography, the first thing you're gonna do probably just a tripod with a camera and the lens. That's the first my advice for you. Start small, and then eventually, if you go deeper, and then you can start to consider which branch of astronomy that you're interested in. Because there are a whole variety of objects in the sky that you want to shoot, and for different type of objects, it might require different kind of setups. So you are limited by your budget, and of course your interest. So start small, spend time, go out to the dark side, and join local astronomy club. Get all those people with experience to teach you and to help you make your decision. Otherwise, you just be spending your money on things that you probably don't even need. That's my advice.
Okay, this is the last question. Is when is the next IOP that the public can join?
Actually, since probably last year, we have opened up IOP to everybody. So as long as you are following our Starfinder Astronomical Society Facebook page, whenever we have IOP going on, we'll be advertising in our Facebook page. And all you need to do is to become a member yourself to join, or you know someone who is a member, so you can contact myself, or you can contact the president of Starfinder, Funky. But maybe I'll share my Facebook page. You guys can add me as a friend. So whenever you see Starfinder is posting anything, you want to join the IOP, you can let me know. I'll bring you in. But on a side note, because of the pandemic and the RMCO still ongoing, any kind of society is not allowed to organize any gathering of any kind. So IOP officially has been halted since March, but I'm unofficially organizing IOP on my own. So yeah, at my Facebook page, if there's any, I'll let you know.
Okay, so that wraps up basically all the questions. So with that, thank you very much for being part of this webinar. So Mr. Dorian, do you have anything to add?
So thank you so much to our speakers, Derrick and Cress. And thank you so much to the Taylor's Astronomical Society for actually setting up this webinar, for also like hosting your webinar with us, Taylor Speakers Corner. Next week, we will be having a forum with the Taylor's Lakeside Dance Club, and the forum is called Dancing 6 Feet Apart. And it will basically be a forum with dancers and dance studio owners and industry experts who will be talking about how the pandemic has affected their livelihoods and what the new normal for the dance industry will look like. So thank you so much for joining us for this session. Please do leave a review on Instagram if you enjoyed this session, and tag us in your stories. We will be posting all of those stories that have tagged us into our little highlights bar. So to all who are joining us on Facebook Live, thank you so much for staying all this while, and we will see you again next week. Thank you and bye-bye. Have a good night.
Bye-bye.
Thank you. Bye-bye. As always, clear skies.
Yeah, clear skies.
Bye. Yep, clear skies.
Okay, so thank you so much, everyone. So I just stopped the Facebook Live thing. So right now is just, we can still talk, or we can decide to leave. Like that's up to us. Usually after our open mics, we will have a cloud session here.
Basically like a mama session.
Like a mama session lah.
Without
Yeah. But speaking of mama, I actually haven't had dinner, so I probably need to bounce. But Chris, if you want to stay and if everybody else,
I think
go ahead.
I think we can put an end to this webinar already, because I think it's kind of late already.
Yeah, it's true.
Okay,
then
so with that,
so much, everyone.
Thank you.
Thank you so much, Derrick, and Cress is gone. But thank you so much for joining us. I learned so much myself, so it's pretty cool. Thank you so much. Bye-bye.
Thank you. Thank you for organizing this. Yes, it was fun.
Thank you.
Good night.
Good night.